Assalamualaikum and hi everyone. So today we're going to learn topic 5 transition elements on ligands and complex formation. So first one is take a look on the definition. What is the definitions of ligand? It is a molecule or ion with one or more lone pairs of electrons available to donate to a transition metal ion. So it means that it can be a molecule, it can be ion, and it must have a lone pair of electrons to donate. Now, next one. What is a complex? A complex is a transition metal ion surrounded by the ligands. Okay. So take a look here. The first example. When these ions are in solution, we are talking about Fe2 plus aqueous. It is surrounded by 6 water molecules. Okay. So these are the structure. Now, the water here is what you call a ligand. So the water molecules is called a ligand. Why is it called a ligand? Because here it says that ligand is a molecule. Yes, it is a molecule with one or more lone pairs of electrons available to donate. You see here, the oxygen in water have that lone pairs of electrons and it can donate it to the Fe2 plus ion. Okay. Next one. The whole entire formula here is what we call a complex. Reason why? Complex ion is a central transition metal ion, which is here I'm talking about Fe2 plus, surrounded by ligands. What is our ligand? It's the water molecules. Okay. And then this arrow here represent the dative bond. Again, repeat what is dative bond. It's a covalent bond in which both electrons in the bond come from the same atom. So here in the water, the oxygen is the atom that donates both of the electron. It's actually not donating, it's more of sharing of the electrons with your Fe2 plus ion. And then here, this is the formula of your ion here, Fe bracket H2O6. Why 6? Because it is surrounded by 6 water molecules. And then the power is 2 plus. And this is what you call an octahedral shapes. Because it has 4 on each corner, 1 above and then 1 below. So you call these shapes octahedral. Now let's move on to the next one. Here I have nickel and I2 plus, and then I have the cyanide Cn minus, 4 bracket and then power 2 minus. Why is the overall charge 2 minus? Here, the nickel here is Ni2 plus ion, and the Cn is actually our ligand. But it's not just Cn molecule, it's actually Cn minus ion. Okay, so the Ni2 plus has an oxidation state of plus 2 and the Cn minus has an oxidation state of negative 1. So if you plug in into this formula, you will get plus 2 plus 4 bracket negative 1 coming from the Cn, and the overall is equal to negative 2. That's why here the overall charge is 2 minus. Now let's take a look on the shapes. So here is our shapes of the Ni bracket Cn4 2 minus. What is our ligand? Is the Cn minus. So Cn minus ions are the ligand. So again, recap what is a ligand. It can be a molecule or ion. So here we are having an ion Cn minus, okay, with pairs of electron to donate. Yes, it has that pairs of electron to donate to the central transition metal ion. So this is your ligand. Now the overall here, you can see just now we have 6. Okay, it can form 6 dative bond. But here we can only have 4 dative bond. What's the reason? You look here. Cn minus is a larger ligand. Thus, a complex ion formed between a transition metal ion and a larger ligand can only fit 4 ligand. So imagine like before you can fit 6 small balls into a box. Now you have a larger balls that you have to fit into a box. Of course, you have to reduce the number, correct? So same thing with this one, because Cn minus is larger, it can only accommodate up to 4 dative bonds. Okay? Next one, the entire ion is what you call a complex ion. Again, what is a complex ion? It's a transition metal ion surrounded by ligands. Okay? Let's take a look on the overall charge. I already mentioned it. Nickel has a charge of plus 2. And then the Cn is negative 1. So the overall oxidation number is -2. That's why the overall charge is 2 minus. Okay. And then here, that is the dative bond. All these are dative bonds. We have the definition as well already. And here, if you have all 4 ligands on each corner, you call these shapes a square planar. It's like a paper. Imagine like you are holding a paper horizontally. Each corner have that ligand. That is what you call the shapes as a square planar. Now, moving on to the next one. Again, we have COCl4, 2 minus. Okay. So, Cl here is your ligand. Again, the same thing. The Cl is not Cl atom. It's actually Cl minus ions. Okay. Because why ligands? It can be a molecule or it can be ion. But here we are having an ion. Okay. And it has that lone pair of electrons to donate to the transition metal ion. Now here again, Cl minus is a larger ligand. That's why it can only fit 4 ligands around the central ion. And then the overall structure here is what we call a complex ion. Again, what is a complex ion? It is that transition metal ion surrounded by ligands. Okay. And then why is the overall charge 2 minus? Is because the CO here, this central metal ion, it has a charge of 2 plus. So the oxidation state is +2. And then +4 because we have 4 of the Cl minus. Cl minus has an oxidation state of -1. Overall will be -2. That's why the charge is 2 minus. Oxidation state is -2. Charge is 2 minus. Here is again the dative bond. Okay, it's from the dative bond is when one of the atoms here, okay, contributed both of the electrons in bonding. Okay, so the Cl providing both of the electrons, forming the dative bond. All of this here is a dative bond. Now, if you have the structure like this is what you call tetrahedral shape. Just now we have square planar, even though it's 4 coordination number, it's square planar. But for the Cl minus, it's even bigger. It have to rearrange itself so that it's more stable. They took the tetrahedral shapes. And then here, example number 4, we have Ag bracket NH3. This is ammonia 2. Now, you can see ammonia here is our ligand. Why? Because, yes, it's a molecule. It's not an ion. It's a molecule. And it has a lone pair of electrons. Remember, the nitrogen have that 2 electrons here, the lone pairs of electron. It can form a dative bond with your silver Ag plus here. Okay. Now, next one, this overall structure is what we call a complex ion. Again, why? Because you have the central transition metal ion surrounded by ligands. Now, why is it plus sign here? Is because the Ag silver has a +1 oxidation state. And then there are 2 of the ammonia. Ammonia is a molecule, so oxidation state is 0. And then it is equal to +1. That's why we have here plus the overall charge. And again, this is what we call a dative bond. Both of this arrow here is a dative bond. This is the definitions of dative bond. Now, if you have a structure like this is what you call a linear structure. It's just like a straight line. Now, the last one, the example number 5, is the CO bracket En3 power 2 plus. Now, if you do realize, this En is an abbreviation. The actual formula is NH2, CH2, CH2, NH2. This is the actual formula for En. Okay. Now, you can see here, En is a molecule. Oxidation state is 0. Now, why is the overall charge here 2 plus? Is because CO plus 3 of this En is equal to CO. The charge is +2. The oxidation state is +2. And then you have 3 times by 0 because En is a molecule. Therefore, the overall is +2. Now, here, this is the actual structure of the En. Short form, they call it En. But this is the actual formula of En. So, if you do realize here, that one is your ligand. It's a molecule. Okay. So, again, what is a ligand? It's a molecule or ion with 1 or more electron to donate to the transition metal ion. 1 or more pairs of electrons. So, you can see each of this this is considered as one ligand, but it can form two dative bonds from each ligand. Okay, so you can see from each ligand here, it can form two dative bonds. Okay, so this entire thing is what you call a complex ion. Again, what is a complex ion? You have that central transition metal ion surrounded by ligands. And I already mentioned, how do you get that 2 plus overall charge? CO has a plus 2 oxidation, plus 3. And then why is this 0? Because the En is a molecule and you get plus 2. That's why the overall charge is 2 plus. Okay. Now here we have a dative bond. All of this arrow here is a dative bond. This is the definitions of a dative bond. Now, if you have this structure, again, if you count, there are 1, 2, 3, 4, 5, 6 coordination numbernya. Then you call it again a octahedral shapes. Now, what is a coordination number? Definition: the number of coordinate or dative bond to the central metal ion. So I have three examples here. The first example, look at the ion in the middle. You count how many dative bond? 1, 2, 3, 4, 5, 6. That's why the coordination number is 6. Here I have nickel with Cn as the ligand, Cn minus. And you count the dative bond: 1, 2, 3, 4. 4 total dative bond, therefore the coordination number is 4. And the last one, I have silver Ag plus here, and then I have 1, 2 dative bond coming from the ammonia, therefore coordination number is 2. Now here, types of ligand. Okay, sorry. So most ligands such as water and ammonia form just one coordinate bond at a time, and we call it a monodentate ligand. What I meant by that is that you look at these water molecules. At each time, it can only form one dative bond with the ion Fe2+. So you call this a monodentate ligand. Same goes to this ammonia here. One molecules of ammonia can only form one dative bond with the Ag, and then the other ammonia will form another dative bond at a time, only one at a time. So you call it monodentate ligands. Here I have a bidentate ligands. What is a bidentate ligands? It can form two coordinate bonds from each ion or molecules to the transition metal ion. So you look at this En, which is the NH2, CH2, CH2, NH2. This is the En molecule. Now, one En molecule can form two dative bond at a time. Okay, that is coming from the same molecules of En. It forms two dative bond. So you call this bidentate. Bi means two. Okay, so each molecule can form two dative bonds. So if you look here, this is another molecule and it forms one, two dative bond at a time with the CO2 plus ion. So here are the lists that you can take a look. You can pause this video. Look at some common ligands and their complexes. These are the names of the ligand, the formula of the ligand, example of the complexes where you use this ligand. Like for example, the example that I showed you just now. And then this is the coordination number. Remember the total number of dative bond it forms. And then if your coordination number is 6, you will have an octahedral shapes. If it is 4, it can be tetrahedral, it can be square planar, etc. And if you have 2 coordination number, it can be a linear. Okay, that is what they meant by the shapes of the complex. Thank you.